Hey everyone, welcome back. In this video we're going to talk about how to, we're going to continue our conversation about how to find the trig function at any angle. So in this example we've been given the point 12, negative 5, and so we're told that our terminal side of our angle in standard position is going to end at the point 12, negative 5, and we want to find, all six trig functions, all six trig ratios at that particular point. So the first thing we're going to have to do is plot the point 12, negative 5 on a graph, giving ourselves a picture to look at. So if I imagine the coordinate plane, the point 12, negative 5 is going to be somewhere down in this region here. So we go over 12, down 5. We're going to call that the point 12, negative 5. So our angle then is going to be from the origin to here. And remember, our angle started in standard position, so if we consider our angle like this, that means that we are looking for the trig function of this value here of theta. So theta would be the angle of rotation there. Now our reference angle is this angle in here. I'm going to call our reference angle x. So if we know that this is the point 12, negative 5, and we consider a right triangle right here with the x-axis, we notice that our reference angle x, right, and this angle here, as well as this angle here, they all form a right triangle. So this is going to be my x value 12, this is going to be my y value negative 5, and I can use Pythagorean theorem to find the value of the hypotenuse. That's going to be a length of 13. Okay, it's a 5, 12, 13 triangle. So what I'm going to do is I'm going to use my reference angle to find the sine, cosine, tangent, cosecant, secant, and cotangent. So we'll start with the sine of theta. Now I know theta is this angle here, right, this reflexive angle, but because we're in the fourth quadrant, right, we should know that the sine is going to end up being negative. Well, if I look at this triangle, remember this side here had a length of, we're calling it negative 5, even though it's really 5 units long. The sine of x would have been 5 over 13. Well, the sine of theta, because it ends up in this fourth quadrant down here, is going to be negative 5 over 13. Okay, and the cosine of theta, well, cosine of theta, again, I'm gonna consider this right triangle here. We have a positive x, right? So the positive x is 12 over our hypotenuse 13. So the cosine of theta is going to equal 12 thirteenths. The tangent of theta is going to be the opposite side over the adjacent side. So normally if we just had a right triangle, everything would be positive, but again, because we're in the fourth quadrant, that means that we have a negative sine and a positive cosine. Well, a negative sine and a positive cosine is going to give me a negative tangent, so we're going to end up with a negative 5 twelfths. So now that I have my three main functions, finding the reciprocal functions is pretty easy. I can say that the cosecant of theta is equal to the reciprocal here. It's going to be a negative 13 fifths. I can say that the secant of theta is going to be equal to the reciprocal of this. This is just going to be 13 twelfths. And that the cotangent of theta is just going to be equal to the reciprocal here, which would be a negative 12 fifths. Okay. Now, if I wanted to find, well, what's the value of theta in any single one of these, there's really two ways I can go about it. One way would be to find what the value of x is by using my inverse right triangle trig. I could use the inverse of any single one of these functions here. Or I could take the inverse here, knowing that the sign is negative, and again, the inverse of any one of these should give me the right answer as well. I just have to do it on my calculator to figure it out. Okay, so that's how you're going to find the value of any of the trig ratios at any point on the coordinate plane. Thanks for watching.